Hey everyone, welcome back. In today's video, we're exploring the builder design pattern in Python. Ever found yourself dealing with complex object creation where constructors just don't cut it? Well, the builder pattern is here to make your life easier. We'll break down how you can use it to create objects step by step, making your code more flexible and readable. So stick around because by the end of this video, you'll be building complex objects like a pro. 1. Introduction. The builder design pattern is a creational pattern that helps construct complex objects in a step-by-step manner. It allows flexibility in creating various types of objects by using the same construction process. By separating the construction logic from the object's representation, the builder pattern makes object creation more flexible and modular. This means you can build different versions of the same object without altering the core process, making it ideal for creating complex, customizable structures. Key characteristic. The builder pattern constructs an object step by step, allowing you to configure it in different ways. By keeping the construction logic separate from the object's representation, you can easily create complex objects with varying features. This approach makes object creation flexible, enabling you to build different versions of an object using the same process without altering the core construction method. It's particularly useful when objects have numerous optional parts or configurations. 2. What is the builder design pattern? The builder design pattern helps construct complex objects step by step, making it easy to create different versions of an object using the same process. It separates the logic of how the object is built from the final representation, which is useful when an object requires multiple parts or configurations. This approach simplifies object creation, especially when the construction involves many steps or options. Real world analogy. Imagine you're ordering a custom burger. You select the ingredients like lettuce, tomatoes, or cheese, and the chef assembles the burger step by step according to your choices. In software, the builder pattern works just like this. It constructs objects in a flexible, step by step manner, allowing for customization without changing the core construction logic. This makes it easy to build complex objects while keeping the process consistent. 3. Why use the builder design pattern? The builder design pattern is helpful when creating an object requires multiple steps or configurations. It allows you to build the object step by step, making it possible to generate different versions of the same object based on runtime needs. By using a builder, you separate the construction logic from the object's representation, which keeps your code clean and easier to maintain. This pattern also provides flexibility and scalability, making it easier to manage complex object creation without cluttering the client code. 4. How to implement the builder design pattern in Python. To implement the builder design pattern in Python, you start by creating a builder class that handles the construction of complex objects in a step-by-step manner. This separates the process of constructing the object from the actual object itself, ensuring that the creation logic is isolated from the object structure. This way you can control how the object is built while allowing for different configurations and representations of the same object. The builder pattern provides flexibility by enabling you to reuse the same construction process for different outcomes. Step-by-step implementation. In this example, we implement the builder design pattern to construct complex objects step by step, separating the construction process from the final representation of the object. As discussed in earlier responses, the builder pattern is useful when constructing objects that require multiple steps or components, and it allows for flexibility in how these objects are built without exposing the construction logic to the client. We begin with the product class, which represents the object we are trying to build. The product class contains a list of parts and provides methods to add parts, add price discount part, and display show underscore parts. The parts in the product represent various components that are added incrementally during the building process. The product builder class is where the actual construction logic resides. This class initializes a product object and defines methods like build underscore part underscore and build underscore part underscore b to add specific parts to the product. The builder also provides a method get underscore product to return the fully constructed product. This approach ensures that the construction of the object is handled internally within the builder, and the client code doesn't need to worry about the details of how each part is added. The director class is responsible for controlling the sequence of the building steps. It takes a product builder object as an argument and uses it to construct the product in a predefined order by calling the builder's methods. In this case, the construct method calls build underscore part underscore score followed by build underscore part underscore b. But the director can easily control the order or inclusion of parts based on different construction needs. The director allows for a high level of abstraction separating the client code from the specific building process. In the usage example, we first create an instance of product builder and pass it to the director. The director then orchestrates the construction process by calling the appropriate builder methods. Once the product is fully constructed, we retrieve it using get underscore product and display its parts with show underscore parts. This design highlights the advantages of the builder pattern. It separates the construction logic from the final product, making it easier to create different variations of the same product without altering the client code. For example, if we wanted to create a product with additional parts or rearrange the building sequence, we could do so by modifying the director or the product builder without affecting the rest of the system. This pattern promotes flexibility and maintainability, particularly when dealing with complex objects that require incremental construction. 5. Real world use case factory pattern in action. 1. Building a custom computer. In the tech world, many companies allow customers to build custom computers by choosing specific components like the processor, memory storage, and graphics card. The builder design pattern makes this process flexible by constructing different configurations based on user preferences. This pattern ensures that users can get exactly what they need, and the system remains easy to extend when new components or options are introduced. Why builder pattern? The builder pattern is perfect for situations where users have varying needs, like choosing specific components for gaming work or casual use. It allows users to customize each part of the computer step by step without needing to configure everything at once. This pattern simplifies the creation of complex objects like a computer with multiple parts by breaking the construction process into clear and manageable steps. Expanded use case. Imagine an online computer customization platform where users can choose components like processors, RAM, storage, and GPUs to build their ideal machines. The builder pattern allows the system to easily create these customized configurations based on user preferences. If a new component like a next-gen processor becomes available, the system can be updated with minimal changes, as the builder pattern makes it simple to extend and adapt the object construction logic. Practical implementation. In this example, we use the builder design pattern to construct a complex object step by step, in this case, a computer object. As explained in earlier responses, the builder pattern is particularly useful for constructing objects that require multiple steps or components. This pattern allows us to separate the process of constructing an object from the object itself, enabling flexibility in the construction process without exposing the construction logic to the client. The computer class represents the product being built, which consists of various components such as a processor, RAM, storage, and a GPU. This class provides a clear structure for what a fully built product looks like. Its underscore underscore string method returns a string describing the current configuration of the computer, such as the type of processor, amount of RAM and GPU installed. The computer builder class is responsible for constructing the computer step by step. It offers methods like set underscore processor, set underscore RAM, set underscore storage, and set underscore pool that allow us to configure the different parts of the computer. By returning self from each of these methods, the builder allows method chaining, which makes the code more readable and concise. Once the configuration is complete, the build method returns the fully constructed computer object. This class isolates the construction process, keeping it separate from the client code and providing flexibility in how the components are assembled. The director class plays a key role in this pattern by managing the sequence in which the builder's methods are called. In this example, the director offers two methods, build underscore gaming underscore peak and build underscore workstation underscore peaks. Each method uses the builder to configure a computer with specific parts for different use cases. For instance, the gaming PC has an Intel i9 processor, 32 GB of RAM, 2000 GB of storage, an NVIDIA RTX 3080 GPU, while the workstation PC is built with an AMD Ryzen 9 processor, 64 GB of RAM, 4000 GB of storage, and an NVIDIA Quadro GPU. The director ensures that the configuration process follows a predefined order, allowing the system to easily construct various types of computers by simply switching the construction sequence. This design showcases the flexibility of the builder pattern. The client code doesn't need to know how the computer is built, it simply calls methods on the director, which orchestrates the builder to construct the product. This decouples the construction process from the representation, making the system easy to extend. For example, we could easily add more configuration options, such as different GPU or storage option, without modifying the client code. Additionally, we could introduce new methods in the director to build different types of computers, e.g., ultrabook or server, by using the same builder logic. This modularity and separation of concerns promote maintainability and scalability, especially when constructing complex objects with many components. 2. Generating HTML documents. Um, When generating HTML documents dynamically, the builder pattern allows for the step-by-step construction of complex structures like headings, paragraphs, lists, and tables. It provides a flexible way to create a tree of HTML elements, each with its own attributes and content. By using this pattern, you can easily add child elements or modify attributes without complicating the process. This makes building HTML documents more manageable, especially when creating complex layouts or dynamic web pages. Why builder pattern? The builder pattern is ideal for creating HTML documents because it simplifies the process of handling complex structures with nested elements and attributes. It allows you to build each HTML element step by step like div, p, or h1, ensuring the correct hierarchy and structure. This pattern gives you the flexibility to easily add or skip optional components such as access IDs or inline styles without affecting the overall construction. It makes the HTML generation process clean, organized, and adaptable to changes or customization. Expanded use case. The builder pattern is perfect for an online web page builder where users can customize HTML elements like headings, paragraphs, or images with various attributes. It allows the system to dynamically generate different HTML structures based on user preferences, making the process flexible and adaptable. For instance, if a new element like a video embed is introduced, the builder pattern enables easy integration without requiring significant changes to the existing code. This ensures a smooth extension of the HTML creation logic, allowing the system to grow and support new features effortlessly. Practical implementation. In this example, we use the builder design pattern to construct an HTML document dynamically. The builder pattern is ideal when creating complex objects like HTML structures by assembling multiple components step by step. As explained in earlier responses, this pattern separates the construction process from the object itself, providing flexibility and readability in creating complex structures without overwhelming the client code. The HTML element class represents a single HTML tag such as div, p, or h1. Each HTML element instance can have a tag underscore name, optional text content, attributes, and children nested HTML elements. The class provides methods like add underscore attribute for adding attributes such as class header and add underscore child for nesting elements within the current tag. The underscore underscore string method generates the full HTML string for the element, including its attributes and children, allowing for easy conversion of the element and its structure into valid HTML code. The Hutton Builder class handles the process of building an HTML structure by providing methods to add child elements and attributes in a chain manner. For example, You can add a child element, add underscore child, or an attribute, add underscore attribute to the root element, and keep chaining these calls to continue building the structure. The build method finalizes the construction and returns the HTML structure as a string. This design enables the client code to easily construct nested HTML tags and attributes without worrying about the internal representation or nesting complexity. In the client code, we demonstrate how to use the HTML builder to create a basic HTML document. The root element is Apple, and inside it we add a head tag, a title with the text my page, and then a body with an H1 header and a P paragraph. The result is a well-formed HTML document that reflects the builder's step-by-step construction of the nested elements. By calling build, the entire structure is generated as a string and printed. This implementation highlights the power of the builder pattern in constructing hierarchical structures like HTML. The pattern allows the user to define each step of the creation process in a flexible and readable way, abstracting the underlying complexity of managing tags, attributes, and children. The separation of the builder logic from the element representation ensures that the client code remains clean and intuitive while still being able to construct complex HTML documents. If future extensions are needed, such as adding more tags or attributes, the system can easily be expanded without major changes to the underlying logic. 3. Constructing skull queries. The builder pattern makes constructing complex SQL queries more manageable by breaking the process into smaller modular steps. It allows you to build queries dynamically, adding conditions, joins, and filters as needed without worrying about syntax errors. This pattern helps ensure that the queries are constructed correctly while giving you the flexibility to customize each part, such as adding where clauses or joins based on the specific requirements. By using the builder pattern, you can create clean, readable SQL queries without cluttering the client code, making the process flexible and easy to maintain. Why builder pattern? The builder pattern is ideal for constructing complex SQL queries because it handles the multiple components like select, where, join, and order by in a clear, structured way. It offers flexibility by letting you build queries step by step, ensuring that only the necessary clauses are included based on the specific conditions at runtime. Additionally, it promotes code reuse, allowing developers to create query templates that can be easily adapted for different scenarios by adding filters or conditions, making the SQL construction process more efficient and maintainable. Expanded use case. Imagine an online query building system where users can generate SQL queries by selecting different options like filters, joins, or sorting. The builder pattern simplifies this process by constructing the query step by step based on user input, ensuring each query is built accurately. If a new feature like a group by clause is added, the system can be easily updated without major changes, as the builder pattern allows for flexible and extensible query construction. This ensures the system adapts to new requirements while maintaining clean and modular code. Practical implementation. In this example, the builder design pattern is applied to dynamically construct SQL queries. As explained in earlier responses, the builder pattern is particularly useful when an object, in this case a query, requires incremental construction through multiple steps. This pattern provides a structured and readable way to build complex objects while keeping the construction logic separated from the actual usage in client code. The queryBuilder class encapsulates the logic for building SQL queries in a modular and flexible manner. It provides methods like select from underscore table, where and order underscore by, each responsible for setting specific parts of the query. For example, the select method takes in the field names to be retrieved in the query and formats them into the select clause. Similarly, from underscore table sets the from clause, specifying the table from which to retrieve the data. The where method allows the addition of conditions to the where clause, supporting multiple conditions combined with AND. The order underscore by method enables sorting the result set based on a specified field and sort order ascending or descending. The most important feature of the query builder is its use of method chaining, allowing you to build the query in a step-by-step and intuitive fashion. By calling these methods one after another, the client code remains clean and readable while the internal state of the builder tracks the query components. Once all parts of the query are set, the build method assembles the full-scale query string, combining the select, from, where, and order by clauses in the correct order. If multiple where conditions are added, they are combined with and to form a compound condition. In the example usage, we see how the query builder is used to construct a query that selects its name and age from the employees table. Two conditions are applied: the age must be greater than 30 and the department must be HR. Finally, the results are ordered by aging descending order. The constructed query is printed and the resulting skull string is select id, name, age from employees where age 30 and department HR, order by age desk. This approach showcases the power and flexibility of the builder pattern in constructing skill queries. It allows the query building process to be abstracted and reusable, making it easy to build different queries by simply chaining methods. The client code doesn't need to worry about the underlying details of query formatting, everything is handled by the builder. This separation of concerns promotes code clarity, maintainability, and scalability, especially when dealing with complex queries. The modular design also allows for easy extension, such as adding support for more skull clauses, e.g., join, group by, without changing the existing code structure. 4. Creating an online shopping cart. In an e-commerce system, the builder pattern can be used to construct a shopping cart by allowing customers to add or remove products, apply discounts, and select shipping options step by step. The pattern simplifies this process by creating a flexible structure where items and promotions can be added incrementally without affecting the core logic. If a new feature like loyalty points or express shipping is introduced, the system can adapt easily with minimal changes. This approach ensures a smooth and modular shopping experience for customers while keeping the system flexible for future updates. Why builder pattern? The builder pattern is ideal for constructing a shopping cart as it allows for customization, letting each customer build a cart with different products, discounts, and delivery options. The step-by-step approach ensures that items, promotions, and shipping methods can be added incrementally, keeping the process flexible and organized. It also handles optional features like gift wrapping or shipping insurance seamlessly, ensuring that these extras can be included or excluded without complicating the overall cart building logic. This makes the shopping experience more personalized and manageable while keeping the system adaptable. Expanded use case. In an online shopping platform, the builder pattern provides flexibility by allowing users to build their carts step by step, selecting items, applying discounts, and choosing shipping options. This approach simplifies the process of adding new features such as same-day delivery by making it easy to extend the cart building logic without disrupting the existing functionality. The system can adapt to new options or promotions with minimal changes, ensuring that customers always have a smooth, personalized shopping experience tailored to their preferences. Practical implementation. In this example, the builder design pattern is used to construct an online shopping cart, providing a flexible and step-by-step approach to adding items, applying discounts, choosing shipping methods, and enabling gift wrapping. As we've seen in earlier responses, the builder pattern separates the construction logic from the actual object being created, allowing the client code to build complex objects like a shopping cart without needing to understand the internal workings of the object. The shopping cart builder class encapsulates the logic for creating and configuring a shopping cart. It provides methods like add underscore item, apply underscore discount, choose underscore shipping, and add underscore gift underscore wrapping to modify different aspects of the cart. Each method returns self, allowing for method chaining, which makes the client code cleaner and more readable. For instance, a user can add multiple items to the cart, apply a discount, choose shipping, and add gift wrapping in a single chain of method calls. This design keeps the shopping cart construction process clear and intuitive. The build method is responsible for finalizing the cart. It assembles all the components, items, discounts, shipping, gift wrapping, and total cost into a dictionary. The total price of the items is calculated by summing the prices of all the items in the cart. If a discount code is applied, the total is adjusted accordingly. In this case, a 10% discount is applied as an example. Once the cart is fully built, the method returns the cart as a dictionary containing all the details. In the usage example, the client creates a shopping cart by adding a laptop and a mouse, applying a discount code, choosing express shipping, and adding gift wrapping. The entire process is achieved through method chaining, which makes it easy to add additional features or options to the cart in a readable and maintainable way. The final cart is printed, showing all the applied features and the total price after the discount. This implementation demonstrates how the builder design pattern can simplify the construction of complex objects like an online shopping cart. By decoupling the cart building logic from the object itself, the system becomes more modular and flexible. This pattern allows for easy future extensions such as adding more complex discount logic or additional cart features without needing to modify the client code or the core logic of the cart. The builder pattern thus ensures maintainability, scalability, and clarity in building structured objects step by step. 5. Building insurance policies. In building insurance policies, the builder pattern offers flexibility by allowing the customization of various components like coverage options, deductibles, riders, and premium plans. Each policy can be constructed step by step, ensuring that the policy meets specific customer needs. This approach makes it easy to add or modify components such as introducing a new rider or changing deductible options without altering the core logic. It ensures that the system remains adaptable, providing a tailored and dynamic experience for both customers and insurers. Why builder pattern? The builder pattern is ideal for insurance policies because it handles the optional components like coverage types, health, vehicle, or property separately. It allows users to customize their policy by selecting the coverage, premium, deductible, and additional options in a clear and structured manner. The step by step process simplifies policy creation, making it easy to add or modify options like riders or deductibles without complicating the overall system. This approach ensures a flexible and user friendly experience, enabling customers to build a policy tailored to their specific needs. Expanded use case. Imagine an online insurance platform where users can easily customize their insurance policy by selecting base coverage options, adding riders like accident protection, and choosing deductibles. The builder pattern ensures that the system can create personalized insurance policies based on the user's preferences step by step. For example, if a new rider such as natural disaster coverage is introduced, the system can seamlessly accommodate it with minimal changes, allowing for flexible and scalable policy building without altering the core logic. This makes the customization process smooth and adaptable to evolving user needs. Practical implementation. In this example, the builder design pattern is used to create a customizable insurance policy. As seen in earlier responses, the builder pattern allows for step-by-step construction of a complex object, in this case, an insurance policy without exposing the internal details to the client code. The pattern provides flexibility in defining each part of the object, e.g., adding coverage, setting deductibles, or applying riders while maintaining a clean and readable process. The insurance policy builder class allows users to build an insurance policy in a structured and modular way. It contains attributes like coverages, riders, premium, and deductible to store the different components of the policy. The method add underscore base underscore coverage allows the user to add core insurance coverages like health insurance, updating both the list of coverages and the total premium. By returning self, this method, like the others, enables method chaining, making the construction process easy and fluent. The set underscore deductible method is setting the deductible amount, an important aspect of any insurance policy, representing the out-of-pocket expense a policyholder must pay before the insurance kicks in. The add underscore rider method lets the user add optional riders, which are additional coverages, e.g., critical illness rider that come at an extra cost. This gives the policyholder the flexibility to customize their policy further based on their needs. Finally, the build method assembles the final policy by consolidating all the coverages, riders, premiums, and deductible into a dictionary. This dictionary serves as the final representation of the policy, containing all relevant details for easy access. In the usage example, the client builds an insurance policy by adding base coverages for health insurance and accident coverage, a rider for critical illness, and setting the deductible at $1,000. The builder step by step method chaining makes the construction process clean, logical, and easy to follow. The final policy is printed, showing all the relevant details such as the total premium, coverages, riders, and deductible. This implementation of the builder pattern highlights how the pattern simplifies the process of creating complex objects. It allows flexibility and customization without cluttering the client code. By keeping the construction logic separate from the policy object itself, the system becomes easier to maintain, extend, and scale in the future. For example, adding new types of coverages or calculating more complex discounts can be done within the builder without affecting the client facing code. This makes the design robust, flexible, and future proof. That's all for the builder design pattern. I hope you found this explanation useful and easy to understand. Now it's your turn to try it out in your own projects. Don't forget to practice what we've covered today. If you enjoyed this video or learned something new, hit that like button and subscribe for more Python design patterns and tutorials. Thanks for tuning in, and I'll catch you in the next video.